先录一下，反正剪掉就好。
因为我怕我会睡着，昨天太晚睡。
现在你年猛了，那么晚睡，3点早大
，3点才睡。
他不是说会
教育我。太高了。
我之前想录早会，我们是不是已经录了放假了？都在考经济学。
都在考经济学。报读经济学。
那经济学就有8题了，我们的那个。
啊？
我们经济学它只给8题，这个要考8题，这要考8题30题。
简历完全。
Okay, so today there are some members from Ministry of Education who will be coming to our lecture. They are going to monitor the lecture condition. So don't worry if there's someone staying at the back of the classroom. Don't worry about that. Okay, so in today's lecture, we are going to cover 2 different topics. One is called so-called the threading. Threading. So what does threading mean? So basically, in computers, we usually run a portion of the code in a series, when basically line by line. And whenever this script is being executed, it's like a thing, so-called a single thread. It's like a path going from the beginning and then go through the script toward the end of the code. However, sometimes we would like computers to work on different things at the same time. So Python allows this kind of request. And what happened was a CPU has a lot of cores. So nowadays computers can operate different functions at the same time. And there is a specific way of coding so that you can run different things at the same time before computer crash. Okay? If you do this too much, your computer could be super slow. And when I was a student, if we do this, our computer will crash. You cannot move your mouse, you cannot do anything, because computer was occupied by all the codes that you request to run. So anyway, when I was a student, it's always dangerous to do a while loop. if we run a while loop, and if it's an infinite loop, it never stops. Sometimes the entire CPU is running your while loop. And when the memory is, when you're out of memory, computer just cannot do anything else. But nowadays our computers are super smart. They allocate the memory by itself. So the purpose of this part of code is that, like this one, is trying to allocate some of your codes in parallel. And sometimes you can have one thread doing something and then pass some of the information to the second thread. So the second thread could be doing its own job with the shared information. So those are words. I'm just gonna show the code. Okay. So threading is a library. You need to import threading. So it's a class. So you need to import threading. Then there are some functions in there. The most useful one is gonna be this one. Threading dot thread. Basically how you define a thread. Whenever you have a line like this, you are defining a specific thread and you want that thread to be run simultaneously with some other threads. And we use target equals to specify which method to be run in parallel. So here is a function defined by yourself. Okay? And I'm going to show one example over here. The fonts are small. Let me make it larger. We don't really need to read these. We just need to read the sample code. Hold on. Let me make it larger. Hold on. So this is one specific, sorry, there's some Chinese. So if you don't read Chinese, I will explain to you. It's a code that is running two different things simultaneously. And the library this code utilized includes threading, of course, random. Random is to generate random numbers. Later on, there's a line that generates random numbers. And time. Time is just to show how much time. Actually, he used this time to pause the code for a short period of time. Otherwise, this is running too fast. Okay. So over here, there's a user-defined function. It's called ask input. So what this code is going to do is to run some kind of random process and then printing some results while keep on asking you to give some input. Whenever there's an input, there's a variable will change its state. And that change will cause this random process to stop. So inside this customized function, he defined a global variable. So this global, like what we learned earlier, whenever we have a function, and when we jump into this function, we have local variables. Local variables only run inside this function, and it does nothing to outside. It's like it's in its own space. It's a local space. Whatever happened inside, it doesn't come out. Only if you return some value out of that local process. So if you define a global variable, that means you are telling the entire workspace, hey, this is a sharing variable. Okay, so if I update this variable, everyone will share that knowledge. Okay, so he's using this turn off as the name of this global variable. Initially, from the main code, you can see turn off was false. So that means he didn't want this turn off. He didn't want to stop this process. So initially, turn off was false. So in this particular thread, 2 lines will be run. First, it will print a line indicating, okay, we're about to do parallel processing. And then he used the input. Basically, he's trying to collect information from you. And what he said right here was to ask you to give some input, anything. So once this function gets some result from you, this process could be waiting for you for a long time if you don't do anything. But once you do something and provide the input, this turn off variable turned true. Originally it was false. After you provide an input, this becomes true. And this change will affect some of the process right here. Okay, so this is like a waiting process over there, waiting for you to provide input. And then it will turn off, this turn off variable becomes true. Okay, now let's take a look at the main process. In the main process, first, you need to make sure this thread is running. So the way to make a thread running is to do it like this. You can define an object small t and say threading.thread. Inside the input, you will say target equals to the name of this function. So this line tells the Python this code is going to be run inside a thread, and this thread will keep running. It will be run simultaneously with whatever you're doing. So this main code is like a mainstream of the entire Python code. In parallel, this thread will be run as well. So once you say threading.thread, target a function, if you say small t dot start, that means this thread starts. Okay? Now, the bottom part is a while loop. This while loop is like the mainstream, what this Python code is going to do. Initially, like I said, threading was false. So the while loop says, if turn off is not true, do the following. And he prints the code is running with a random number. Okay, with a random number. And then he used time.sleep to wait a little bit for 0.1 second. Just 1/10 of a second. And if you do nothing over here, this turn off variable is always false. So this will keep running until one day you provide some input right here and turn off become true. So this while loop will realize, okay, turn off now is true, then this will stop. Okay, so this is a way for you to run 2 different things simultaneously, and this is one example of how you can do something in this part and affect what the other part is doing. Okay, so this is one example, and the PowerPoint will be shown in our course web page. However, in this slide there are too many Chinese, so I think for foreigners it's difficult to follow. That's why I created another example to show you how to do parallel processing in Python already. I'm going to show you right away. So this is another example of how the variables is being shared. Okay, so let me tell you about what I'm planning to do. Basically, in this example, I want you to try this later on. In this particular example, I want to random generate numbers, and then I want to evaluate some functions. So it's like a solving for a math problem. But in this particular one, I'm trying to find the minimum point of a function. Okay, why is that? Over here, I have a second thread. I have z equals to x squared plus y squared. So it's like a second order function. And you know, the minimum point is basically 0, 0. If x and y are 0, z is 0. It's impossible to find a different pair of xy that gives value lower than 0. So minimum is 0, 0. But I pretend I don't know. So over here there is like an error value. The error between the function and the minimum. I know the minimum is 0. So basically any random xy gives a value of z, and the z value basically is the error. So when in this second function, I only compute my function value of x squared and y squared, and I compute the error. When I have that, I will print some results, my x, my y, and the error. I only do this. I will keep on computing at random x, random y, and what is my function value z, and what is my error. But in this code, I don't change x and y. X and y, I don't even know what x and y are. In the other code, I use random generator. When the error is large, I will keep on generating random numbers. So random is a library that I use to generate random numbers, and random will generate random numbers from 0 to 1. So it's just randomly generated. So I use x equals to random.random, y equals to random.random. So basically, whenever this first thread is running, x and y will be changing. Since I use a global variable to share the information of error E, variables x and y, those information will be shared to the other thread. This will be updated to the other. Okay, so in the second thread, the values in here will be changed all the time. Okay? So okay, we can observe how these two threads are running later on in the screen. So let me show you what's the main code. I define a T1 and T2. They are threads of target equals to function 1 and function 2. And then I say T1 dot start, T2 dot start. They are both written in while loops. This doesn't guarantee both threads are running in the same speed. Maybe over here it's faster, maybe over here it's faster, we don't know. There are just two while loops running at the same time. Okay, so let's try it. I will show you. So on the right hand side you can see a lot of numbers are running. One day it will stop when we're lucky. It's running. We're not lucky enough. Maybe no luck this time. Because you need to be so close to 0, 0, then it will stop. There's no systematical way to stop it. Earlier when we tried, we were luckier, but not this time. Maybe I should change the code a little bit. We're not so lucky this time. Okay, maybe I make the, let me stop. Okay, this is stop. Okay. Yeah. How do I stop? Okay. Really? That stops? Oh, really? Oh, okay. That's a way to stop. Okay, thank you. Maybe I should make this. I made this too tight, so let me change to a greater value. So we should be luckier this time. So let me run again. Okay. Okay, now we have it. Yeah. From here, earlier I said when the error is larger than 10 to the power of negative 3, basically 0.001, then you can stop. If you have any result that is larger than 0.001, you cannot stop. You need to keep on randomly search for xy. So this error will become small enough. But last time we were not lucky. That's why I changed to 10 to the power of negative 2. That means 0.01. Okay. Now from here on the right hand side, you can tell the bottom line somehow runs faster. So random generator probably is a slower process. Over here, we're only doing math and print. So random generator runs slower. How can I tell? Because from this line, the values never change. See? Never change. They never change. Until this line, xy changed. So the bottom one is a faster process. It will continue to run this while loop without caring about how fast the other thread is. So over here, if I scroll up a little bit, you can tell among all these, the bottom line, the bottom thread has been doing this while loop. But within all these while loop, the first thread is still computing. Okay, so from here, you can tell both threads run in their own speed. And they are running simultaneously. Okay? This stops until in one of the process where a random X like this was received, and over here another random number was received. At the end, the x squared plus y squared equals to a z number, and this number is following my criteria. This number is smaller than 10 to the power of -2. So when that happened, right here, this because this one runs faster, and this one prints out the result. When this one realized, hey, there's a value change, this one stopped because the while loop over here realized the error is smaller. On the other hand, maybe this one haven't received the information of E yet. It's still computing random number. So maybe over here, when it's running a next iteration, then it realized, okay, E is smaller than this number. So it stopped. So I believe the first thread stops a little bit slower than the bottom one, because this one runs faster, this one runs slower. But it's okay. They both stops at the end. Okay, now you understand. In real life, when you are building a system and you want a system to run multiple codes at the same time, they may start in parallel, but they may not start exactly at the same time. They can stop, but their stopping time may not be exactly the same. Just like the example I'm showing here, this one's faster, this one's slower. So we only see the moment this stops. It doesn't guarantee this one is stopped. I believe this one, when this line happened, this line is still generating some random number. Okay, and let me see. I was right. If you look at the variable space, you see the final result of xy is 0.3 and 0.4. It's not this one. How come? Because while this line stops, it shows the result, the last result of the second thread. Like I said, the first thread may be still running. So the first thread is running the last process of generating random numbers. Then it goes to the while loop and realizes, hey, error is small. Then it stopped. However, the floating number, the last one, the first thread run was a number that are logical. Okay? Actually, that one is, no, it's a different one. Yeah. Okay, so that's one exercise. I want you to try it, but it may make your Python not stop. So for the criteria over here, do not make a very small number. Okay? Otherwise, it will stop. It won't stop. If you want to shut down a while loop, a TA just told me you can just close the console right here. Close the tab of the console, so that entire console will be stopped. like you just click the close. Then it will generate a new console, and the previous one will be just stopped. That's one way to stop it. Okay? Otherwise, I was trying Control C to stop it, it doesn't. Okay, now you try it. Try this one.
来一个。是你没想到的那一个。
不知道是谁，不知道是谁。
你是哪一个？
那个照片。
你好像打一个音效，然后还没到呢。
So while you are trying, let me try another thread, just to make it more fun. But you only need to try the first two threads. I'm gonna do.
听到了，听到了。
行啊，你跟上次约，
跟谁会来约？
我帮你约。
我帮你约。行啊，今天会有人录。
谁？谁讲？
我有点开心。
不然谁？他是谁？你谁啊？
今天有点开心。
不然谁会录我啊？
你可以说他跑。
他 很多人画出来很少。
天幕离子，上次上帝之看那等到一个模式，那就会输了。太牛逼了！
会把它画大颗。
太恶了。恶魔机也是我。啊？你讲是啊？
我说要把那个点画出来。
你先讲一，你先讲一次，我们今天就不去。
我要有点想要写快。我也要写快。对。为什么？不然他只画一次。
哇，你跟冠志越好。
所以他就一直画。
你改天看冠志失望。他换的时候，把它秀一下。
但是我是用后的。因为我是跟好。习惯没有我的，那我怎么可以更新？
没有，我已经习惯了。
为什么我一直去建一个人像，然后每次画新的。
礼拜六不就有去吗？
而且他没画，都画哪去？
屁呀！你那才是拜托，你那是真兵，那不就我？
他懂那是什么？
你那才是拜托，你这拜托的误解。
可是不需要后面，不需要后面。
太阳流水。
对啊，
我是美国，我去拿金条，我买水。
虽然是皮厚。没画。啊？好。整天讲什么语言？
有睡啦，我当然知道有睡了，睡多久？4个多小时。你干嘛？
有。
玩脑子。那就不用了。
还有一个化学知识。
小啊 ，scanning 的话就是要搞机器。
哎，李准，我买纯三，
因为我没有记起来，我都是乱去查。
等你好的纯水。你就看我当那个锤子手，筋骨，就在往哪榔头。
另外那个小孩，那个地感知识，然后呢，他下一篇就是说，地主有人说你怎样啊？谁说的？我锤死他！
我叫干嘛？我锤死他！超级好，才2岁而已。
3点钟就生气。
还在用尿看尿不了叫什么？
尿不湿。
不才2岁。hold住了。最hold住了。
Y 要是在 list，就它有推到 X list 和 Y list， 再把 X Y list 用它。
那就是要存，我就不想存了。如果我要一个不存的翻译，
那你记得有一个大姐姐，
对吧？就好像你收 data，
那一届
这样把它记起来。记起来你会有那个会一直有，不会啊？
我们在准备考试的时候就有看过它，
好吧，
蛮漂亮。
那是船吧？
那就是
不是，然后有点壮
更加
那女生然后这种
围肉啊，
围肉，吓死我！
我一直有看，
想不起
但是我是不是一开始要建一个空的？
对，他每次都开一个
空的，
我最喜欢这个
空的是
X 的，
连续看到点。
那如果这样的话，那我这边就是
太夸张了。
刚最后一个的话就是，可以这样吗？最后一个什么叫？
我想不起来。
我记得可以叫做
搞在一起。他跟你姐姐搞在一起。然后那个给我停车钱的3天还4天吧，那个女生的妈妈来找才好好笑。
他那女生有大很多岁，那没差吧？妈妈还阿宝啊，阿布都已经生了，阿宝啊，该要阿皮哦，
阿弟啊，
贤宝。哎呦，你懂看哦。
你看
看群主我也要看，没有
所以
这个也还好啦。
你注意。
这个有没有说你今天别想耍一样？
有种就是尽力
这样嘛，然后我对你的控制，
经济人不是考试，堵得到我就跟你练球，堵得到我就跟你练球。
这样的话，
就是差点，我们考在
每次花全部
考在是在155，
应该可以了，试试看。不秀啊，好像
真的，这个有一个屌的，
就是要 hold 住。
你看啊，对。
说什么了？
暂停。
从这个串了这个，然后就是从开始因为他在做这件事情。
然后那个哦，我那时候没有暂停。
他还有一个很屌的，他就说，那个
你刚才写错吗？
他就闪光，他不是会反光吗？今天手机坏掉了，然后就
debug模式。哦，好，debug，
我昨天看到了。
看你收手吗？
啊？
收手吗？
确实，看我没有留。听这种歌，听这个，天价还可以。
debug 要怎么？
人在讲。
好，哦，
我们两个智障。
我操！世界上有2种女生，一种是右边这种，一种是左边这种。
Pray 不会进去，debug 没办法进去，
很显然。
对啊，进去。
哇，好有爱。
debug 模式没办法进去。
超可爱的。
OK， 不画了，不想画。不画。
Okay. Okay, so did you see the process, random process? I was trying to make a third thread to plot the result, but it didn't work. So I give up. Yeah, does your process work? Okay, if it works, to be honest, even my students, we don't use thread so much in research. So I plan not to spend too much time in threading. But maybe in the future, you need to run codes simultaneously. Maybe threading will be helping you. But in my lab, we rarely use threading. So I'm moving on to the next topic for today, which is highly used, actually. It's NumPy, okay? So num represent numbers or numeric. So NumPy is the library that helps you to do a lot of math. It's really useful. It's like in my research, in my lab, NumPy is the library that we must import in our codes. Okay, so for example, it allows you to have vectors or matrices. And when we do research, usually we handle vectors and matrices, and this will be really useful. When you try to generate vectors, you use array, okay? And then if you want to, let's try to build a vector, and let's run summation of two vectors. Let's directly try it in Python. So what you need to do is to import NumPy, okay? And because you are going to use NumPy for a lot of places, you can save it as a shortened name. For example, NP represent NumPy, okay? And you can define a variable, say NumPy dot array, okay? And inside, what you're going to do, you are going to define as a list. So over here, you can define a list. For example, 1, 2, and 3. Okay, this is how you generate a NumPy array, basically a vector. Another one, NumPy array, for example, a list right here, for example, 2, 3, and 4. Now you can say z equals to x plus y, yeah, and then you can print the result. Okay, and let's see how it looks like. Okay, you can run this part of code. You realize it turns out it ends up with two arrays, x and y, and because two arrays summing with each other, and z is another array. Okay? Let's try another example. If I say u equals to NumPy dot array, but this time I'm doing, let me try this. Okay, I have to just need to make sure I need another variable. let me just try different things. Okay. So how about matrices? If you would like to have, earlier we have arrays. We define them in a horizontal format. Now you can have a matrix being defined in this way. We can define the first line with a bracket right here and a comma, then another array in the same size, and use another larger bracket to contain them. If you define in this way, basically you are specifying the first line of the vector and then second line of the first line of the matrix and then second line of the matrix. So it becomes a 2 by 3 matrix. Now I'm showing you transpose. Actually, I should print both of them. Print U, and over here I'm showing you this is transpose. Okay? So from here, from the result, you can tell the first way of defining a matrix gives you a 2 by 3 matrix. When you transpose it, it becomes a 3 by 2 matrix. Okay? So please try that. If we use the default functions in Python, it doesn't allow us to do something like a transpose. Okay? And also, if you like to have matrices, it's not easy to have matrices in the original way of definition. Okay, now let's get back to the slide. So now defining vectors become pretty easy by using array. You can even do some math. Now, yeah, I already covered this. This is how you generate matrices. Okay? Let's try to see. Yeah, I did transpose as well already. Okay, now let's try to do some math. Let's try to do dot product. Okay? Because dot product is so commonly used in math. So we can just say, I'm going to do vector x dot vector y. Okay, the way to do it is to use the name of the vector, the first vector, dot, and say dot, bracket, and the second vector. So I'm gonna define that as just say for example, let me think of a name. Just A equals to. So now I'm going to say X, a true dot, and then dot as the dot product bracket, and put y in there. Then this is actually the operation of dot product. So basically, like an x dot y in math. Okay, so when you after that you can print out the result. So what happened was it operates 1 times 2 plus 2 times 3 plus 3 times 4. So it's gonna be 2 plus 6 plus 12. This you can. Okay, so the staff from Ministry of Education came, and I need to be interviewed for 10 minutes. So I never take a break. Now is the first time I take a break. Why don't you, take a break for 10 minutes. If you want to continue to practice this part, go ahead, or just do nothing. You can go to the bathroom if you want, but we will be back 10 minutes later. Okay? And they will be monitoring the lecturing after my interview. Okay, start your break. Okay, so sorry. Since they are here to monitor not only me and also you guys, and they are going to take videos of the entire process for lecturing. So they need you to agree to be videotaped. So they are going to pass around a sheet of agreement. Please sign the agreement. So in the future you don't sue us. Okay, so my TA will help the staff to pass around the agreement. Please sign, and then they will collect. Okay, please stay calm. Don't be too excited. I know you guys want to be YouTuber or whatever, but stay calm, okay?
你就继续骗我懂，骗我一口。人家等我，他说我要签我去韩国当面试生。不知道他讲什么屁话。韩国的排球练习生。我英文虽然不好，但也没有到那么差。过分了。
那个同学，学校名称请帮我写台科大，然后学院写工程学院。对，谢谢。有人是不能被录影的吗？有吗？如果有的话，请举手。好，谢谢。
我没有穿西装耶。
你这是穿排球裤。
所以不能被拍就可以下去。
他如果被拍可以不
如果
要被打。
被拍的话，可能要坐旁边一点，就是不会入境的地方。
你不准，你一定可以被拍。
强人所难。
你这没带笔，已经是来打球。哎，对，我也没带，没带铅笔球，没带书包。
你在那里有拿到吗？
也没有带书包，我只有带钱包、钥匙跟手机。
来啊，交给我。还是要我照嘛？
错。Police Council 哎。
自己拿自己的，自己交。
这样我以后考雅思会打包卖掉。
哎，快点帮我解读一下，这个字太多了啦。
谁看？文件第一折结合。在签名。第二个。Print name 签你的名字。傻小，为什么签名然后
下，
这要签就是该不要签那种日期，他说工程学日期。
哪里要写工程学？啊？哦，那个college 哦。
college 是
学院，对错
college 是学院。
对啊，college 是学院啊，对，对啊，对，就是college 是学院。
办雅思的是这些。我买雅思的时候就是从这个。
我想下课，
是这样。
拜托啦！
我签完这个。
拜托啦 ，Emily， 拜托。他是 Emily 对吗？
叫错，乱取
乱加。乱加。这个另外一个都不跟我讲，我一直叫他背。这要签2次名字，确定吗？
翻译签名啊 ，Prince name 就是
小明。小黑。
Prince name 就把名字写下来啊。
Emily。要不然什么 ？HD。Tiffany。Apple。要签2次名。
第一个是签名，
啊，
然后第二个就是你的名字
小明。
也是签名，郑凯，写漂亮一点。
那第一个你就随便签。
你要写草书，第一个写草书可以。
阿华同学。
那多给我几张我会变可是我草书跟郑凯一样。
因为写字太丑。
没有啦，草书就很漂亮。几号
5月。
几年？2023哦。5月3号。送你我的签名。
教育不会流程。
对，第一个很不草书哎。看到第一个是。
我第一个就是这样子啊。
刚刚打个勾。
对呀。这么快啊？
我签个名字就出来。没有什么屁话来多。
Okay. Are you familiar with dot product? I saw someone not sure about dot product. So it's not a course about calculus, but I could give you some information about dot product.
啊，他会。
Okay.
再玩1个礼拜就不知道了。
A vector could be written as, for example, the first component of the vector, the second one, or the third one. Okay. Later on in the future, there will be more ways to write a vector in many of your courses. It could be written as a you could say it's something like this. Sometimes we use IJK. I'm not sure if you have learned this already. Okay? Sometimes we do this. This is representing a scalar, a value, basically the length of that component along that direction. So we call normal, it's like a basis, normal basis. And actually it represents a vector 1, 0, 0. It only indicates the direction, but doesn't affect the size of the component. And sometimes in many engineering courses, we would like to rewrite ijk as a different way, like E1, E2, and E3. Sometimes we would like to write in this way. Why do we do that? Because if we do that, we can write this whole thing into a summation form, AIEI. I goes from 1 to 3. That gives us a lot of convenience for mathematical derivation. So what is a dot product? I'm sorry about that. So if I have a vector A dot vector B, what happened was you are doing A1, A2, A3 dot B1, B2, B3. Okay? So the dot has to be written, otherwise you cannot multiply two vectors in this way. And for convenience, there's one way to compute A dot B is to transpose the first one. So usually we write a capital T on the superscript of A and write B right here. So it's like a A transpose B, but this time no dot. Because when you have vector A dot vector B, the more convenient way to compute this is to transpose the first one and do matrix multiplication with B. So in this way, it's gonna be A1, A2, A3 times B1, B2, B3. If you are not familiar with dot product, then this is the way. Once you have a horizontal vector A1, A2, A3, and a vertical vector B1, B2, B3, you can do matrix multiplication. At the end, you would have A1, B1 plus A2, B2 plus A3, B3. In fact, it's basically sum of AI, BI. I goes from 1 to 3. Okay? So this is like a supporting material for you if you are not familiar with calculus or vector operation yet. Okay? It's very common. It's commonly used later on in more advanced lectures, almost in different fields, mechanical, civil. I'm not sure about chemical engineering and material science. You should be able. You should need to use it. You probably will see it sometime when you take more advanced courses. Now, since we're learning Python, we're talking about functions that does math for us. So I believe it's good to know how to do dot product inside Python. Okay? I will not take away this. So after the lecture, you can come here to take a picture if you're not familiar with this. Okay, so in my slide, I actually include two more kinds of products. One is called the inner product, the other one is called outer product. They are so rarely used. So I'm not going to cover those. They are usually used for really, really advanced calculus or engineering mathematics. In my research career, I have never used inner product and outer product yet. That's how rare those products are. So I would say I will skip those because you are not going to use it maybe in the following 4 years. Okay? Now I'm switching to the next topic about NumPy. So actually, this one we covered this one. Actually, I used this one once or twice in the previous lectures. but I never officially introduced how to use it. This is a way to generate a range of numbers. So the difference between this one and the default range function is that this is the range function that allows floating numbers. In the default way of defining a range, there's no A right here, just range. It's a range, it generates a range of integers. It doesn't allow you to have floating numbers in this range. However, in mathematics, in engineering, it's so common that we use floating numbers. That's why this function is being prepared inside this NumPy library. So what you are going to do is to use NumPy dot, so a range. You are going to specify a starting number, an ending number, and then the distance between each component. So it's like a step, okay? So let's try it. In Python. So let's say we have a B vector. I'm gonna say NumPy dot a range, and let's start from the easy one, starting from 0 and ends with 10. The gap is 1. So if you do that, you have 0, 1 until 9. So just to remind you, usually the vector stops when it sees the ending value. So when this sequence sees this ending value 10, it stops, and 10 is not included. Okay? That's why at the end we have starting from 0 with a gap of 1, we have 0, 1, 2 until 9. It doesn't include 10. Okay, that's how it's being defined. Let's create another one, C equals to NumPy, a range. So let's say 0 dot 10.1, for example, like that. You should be able to see 10 this time. Because for the ending value, I make it larger a little bit. It's a 10.1. So if you start from 0 and you add 1 for every sequence, you end up with a number 10 being included, and of course 10.1 won't be seen. So then you have a vector of 0 until 10. But now please focus on the variable type of the result. When we define B, the starting value is integer 0, ending value is integer 10, the gap is integer 1. So NumPy will generate a vector with the variable type of integer. It won't just push it to a floating number, because when you define it, there's not a floating number here. So the function aRange will figure out you are actually defining a vector of integers. So over here, when you get the result, it's a collection of integers. But within your definition, if anywhere you specify one of the value as a floating number, to be safe, this function will just save the whole result as a collection of floating numbers. So from here you can see it's an array of float, even though the results are just integers. But they A range will save it as floating numbers. So over here you will see 0 dot. The dot means this value is being saved as a floating number, even though it equals to an integer. So at the end you have 10 dot, 1 dot, 2 dot, until 10 dot. They are floating numbers. Now let's try to start with a floating number, for example, 0.1 ends with 10.1, and let's say the gap is 1.1. Of course, we tell a range to generate a vector with a bunch of floating numbers. Of course, at the end, you will have a collection of a bunch of floating numbers. Okay, so let's try to see it. So over here, we can tell you end up with 10.1, 1.2, 2.3, 3.4 until the last one is 10.0. Okay, so in Python, the 10.0, the 0 is not shown, but it's a floating number. So now please try all these three. Make sure you know how to do it. Just for fun, you should be able to do dot product between B and D, because B and D are having the same size. So just for fun, E equals to B dot D. And then let's see. You end up with a result of E, just for fun. I generated a vector of B. I generated another vector of D. B is a vector of integers. D was a vector of floating numbers. They happen to have the same size, 10 components. C had 11 components because 10 was included. So D has 10, B has 10. You can do that product between B and D. So E was the result of B dot D. Just for fun, let's try D dot B. It should give the same result. So just say E1 equals to D dot B. Mathematically, they look different, but the result is the same. Why is it the same? Because when you do dot product, the vectors can be reversed. They're just multiplying with each other and summing up. So the result won't change if you swap places between A and B. It's the same result. Okay, so if you are not familiar with dot product, A dot B actually equals to B dot A. If you would like to know. So from here, I just show you we did B dot D in the code, and we tried D dot B in the code as well, and it turns out the results are the same. Okay, you can go ahead and try it. So please try all these in your own way. I'm actually curious about something. Let me just try it. Okay, so please make sure you try those. Okay. Now let's move on to next part of the PowerPoint slides. Okay. Now there are different ways of generating a vector, and line space is another way. Okay, so it's very similar to a range. So if you do this, it will generate again an array of numbers with a starting value and a stop value. Okay, and you can there are some properties that you can set up. For example, you can assign number of samples inside the entire sequence. Okay, so it has certain functionalities, and it seems like very similar to a range. Why do we need a different function like this line space? Because later on I'm gonna introduce something called log space. It allows you to generate a sequence of numbers with logarithm. Okay, so let's practice line space first. It's very similar to a range. So for example, I'm defining f as a numpy line space, and then I call it line space because it's or linear space. Yeah, LIN represent either a line or a linear. So let's start with starting number. Let's try 0 and 10 again. But this time I'm gonna say num equals to 5. Okay. Let's see what the result is. As a result, you can tell. I'm sorry. It's not exactly the same as a range. The slight difference is that it distributes numbers within a range. So earlier when we say a range, we want to start with a number and then finish with another number. For line space, we want to assign numbers from a starting point to an end point, and in between, I want you to specify intermediate points, but evenly distribute. And I'm gonna specify the total number. In this case, I chose 10. I chose 5 of them. So what happened was, within this range, from 0 to 10, this could be my first point, and 10 will be my last point. So what would be the middle point? That would be the middle one. It's gonna be the third one. It will be 5. And what would be the one at the 1/4 position? That would be my second point. It's gonna be 2.5. And over here, the third quarter point is gonna be 7.5, and it will be my fourth point. So line space is like we define a linear space with a starting point and an end point. Tell me how you are going to evenly distribute the range. Okay, so that's the difference between a range and line space. Line space, I use a starting point and an end point. I specify how many points I want. At the end, I have 0, 2.5, 5, 7.5, and 10. Okay? So please try it and then recognize the difference between A range and line space. So later on, we're going to try a log space. Basically, the way the points is being determined is under a rule of logarithm. So please try this part. NumPy dot line space. Okay, so if you are still trying, don't worry. I'm gonna just quickly jump to log pi. The difference is the phrase that you're using will be changed to log. Okay, so I'm gonna just try this with exactly the same way of definition, but this time I'm using log space. So what will happen is what will happen is, I'll tell you what will happen. Okay, so what happened to log space was you end up with a vector of numbers with exponential values that has a base of 10. By default, the base is 10. So what does that truly mean? That means you are looking for having because earlier when we have the line space, we end up with 5 values equally distributed in the range of, in the interval of 0 to 10, right? So now we are still trying to generate 5 numbers, and we want something to be evenly distributed, which are how you sample positions from 0 to 10. So meaning we're still sampling 5 points from 0 to 10. However, this time when we say log space, at the end we will get 5 different numbers, and they will be 10, 5 tens, and their powers become the sample you collected. So 10 to the power of 0, 10 to the power of 2.5, 10 to the power of 5, 10 to the power of 7.5, and 10 to the power of 10. So this is a way for you to generate a sequence of numbers with a logarithm base of 10. And the powers would be evenly sampled in the range of your starting point and end point. Okay, so I think this is rarely used, but since the function has been introduced, I would like to understand what's going on. So over here, I also try to manually create those 5 numbers, 10 to the power of 0, 10 to the power of 2.5, 10 to the power of 5, 10 to the power of 7.5, and then 10 to the power of 10. And you can try that and try to visualize them in the workspace. You will realize they are the same. The first one is 1, second one is 316, second one is 100,000, third one is a large number, 131622776, and the third one is a large number with 10 zeros. Okay, so from here, from this trial, you will realize log space is exactly doing what I said. So why don't you try those codes and try to understand what's going on. Okay, I'll give you some time for these. So try to create line space and log space, and if you want to prove yourself, you can try to generate a list of numbers with exponential powers, like what I show you on the board, just to justify the results are correct. If you would like to know how to generate 10 to the power of 2.5, 10 star star, star star means power. 10 star star 2.5 means 10 to the power of 2.5. Okay, so please try it. If you have any issues, you can raise your hand. line space is actually very useful. Let me share some experience about line space. When we write computer codes to solve some kind of problems, sometimes we need to sample positions. And within a linear range, sometimes I want to specify how many points I want to use, and I want to specify the starting point and the end point. If you have to manually calculate which are the points to achieve that by yourself, it takes a lot of time. So line space is really a good way to evenly distribute a space from 0 to 10 with specific numbers. So that's really useful in my research. For example, like I show you for many times, I would like to solve math problems. And I sometimes try to find a proper position of a function. And sometimes I need to evenly distribute the space to find the position I'm looking for. So with line space, I can easily specify the positions of my sample. A range does the same, but if I have an arbitrary starting number and arbitrary ending point and a specific step size, I don't know how many points are there. I need to do some math to realize how many sampling points are there. Line space specifically assign number of points. So sometimes line space is more useful for me. But A range, of course, is commonly used. So please try to memorize those two functions, because later on when you do projects, you may need to generate arrays like this. Okay, I see most of you finished the trials. Okay, I think I would like to introduce another really useful way to sample the space, which is called the mesh grid. Mesh grid. Okay, so let me show you the slide first. So a mesh is like a grid. Am I explaining? Okay, mesh grid is like generating a 2D space with sampling points, and those individual points forms like a network, just like how the figure looks like. You can see you can generate sampling points in this square area, a triangular area, not triangular, rectangular area. And you can evenly distribute the X space and then evenly distribute the Y space. Okay, and then you end up with, in this particular case, 3 times 4, 12 points. It's a really good way to have points evenly distributed in the space with some systematical order. Because when later on, for some applications, you may want to sample those positions in order. So the mesh grid helps you to achieve that. The way to define it is as such. You first need to generate an array, basically a vector. and then generate another vector. So those two vectors will be used for mesh grid. For mesh grid, you need two inputs. The first input is a first vector that you specify, basically the locations of your grid. And the second vector will be, the first vector represents the positions along the first direction. And then the second vector represents the positions for the second direction. So with 1, 2, 3, 4, and 7, 6, 5, it generates this mesh with positions of 1, 7, 1, 6, and 1, 5, 2, 7, 2, 6, and 2, 5, 3, 7, 3, 6, and 3, 5, and so on. So it helps you to have this collection of coordinates with all kinds of combinations between the first vector and second vector. And the way to get the collection of the results, you need two outputs. The first output contains all the x coordinates. The second output contains all the y coordinates. And you need to specify it this way. The first output, comma, second output equals to numpy.mesh grid, bracket, and the first vector, comma, second vector. With that, you will be able to collect the x coordinates and y coordinates in a sequence. And they are actually results of that grid. And over here we use something we haven't introduced yet, but we used several times already. I'm going to use PyPlot to show the coordinates. Over here, I'm going to plot out all the x and y coordinates on the figure and then show it. So let's try this part of the code. So earlier we already have array of x, array of y. We can make good use of them. We can directly say xx, comma, yy equals to numpy dot mesh grid, and then you put your x and y there. So it should gives you a grid, points for the grid. At the end, you can check your variable space. They are 3 by 3 matrices. And basically, they are the coordinates of the samples. Now I would like to show them on the screen, show them in the plot. So I need to say from matplot library, matrix plot library, import pyplot as, I'm going to use capital P for my pyplot, okay? Okay, now I can then just say capital P dot pyplot. Just plot. Capital P dot plot, and then put xx and yy in as the input of plot, and then I'm gonna say the marker. Marker indicates the shape of your drawing. Marker equals to dot. So it will be a bunch of dots. Color, I don't care about color. And turn off the line style. Line style. If you don't turn off the line style, you will see the lines. So just say none. None means no lines. And then say p.show. P.show shows the plot. So run the code, go to the plots, and then you see all those points. So how come it was drawn with 3 different colors? Because they are matrices, and Python will draw them array by array, line by line. So whenever they draw for the first line, they specify as like a one set of the plot, and it was specified as a set of drawing, and then second set and a third set. So let's try to turn off the line style. Just keep it as lines. Then you'll realize Python is truly doing what I told you. They treat the matrices as a bunch of arrays. They treat the first set of arrays as a first collection, first set. And the first set was drawn and being specified as the first object. And then the second set of points will be drawn as a second object. So when you see this, don't feel weird, because when we generate a mass grid, they are basically collection of arrays. And then for PyPlot, they were considered as 2 different sets of points. Okay, that's why the first, second, and third sets of plots were made separate. But if you want them to look like the same thing, what you can do is to turn off the line style, just like what I did in the first time. Just say line style none. You will have results without the lines, but they are in the same color. So you can specify a common color to them, so people don't feel like you are drawing them in separately. So just say color equals to, you can specify them as any color you want. For example, R represent red, so they become red points. So now they look like being drawn in the same time. Okay? So please try all these. I'm going to get rid of some of the spaces so you can see the whole code. Okay? Over here, I already have 2 arrays, X and Y. I used them in MashGrid. So for the X coordinates, I use a vector of X, which is 1, 2, and 3. And for the Y's, I use the vector of Y, which are 2, 3, and 4. So at the end, I form a grid like the drawing. And I use the function MashGrid to generate a bunch of outputs, basically collection of the XY coordinates. I save them as 2 variables. I need to do that. The first variable I call it XX, comma, second variable YY. So XX and YY would be vectors, and actually matrices, in the order of your mesh, and you can plot them. You can plot XX and YY. So basically, you have two matrices. One has all the X coordinates, the other one has all the Y coordinates, and they are placed in a sequence, in an order that follows how the mesh look like. Okay? So for PyPlot, first and second variables represent, needs to be the X and Y coordinates that you generated. And there are some properties to be specified. First, if I say marker equals to dot, dot means you are drawing like a small circular dots. Line style means I don't want to see the lines. Color means I want to specify the color of the dots. P.show, make sure you plot it on the figure. Okay? So that's everything you can try. Please make sure you can do it. After this, we can start to do our exercise for the day. Let me see if I have anything else. Hold on. Oh, I have functions. Actually, I have more. Yeah. So please try this first. Make sure you know how to do mass grid. Because it's hard to justify whether your mass grid is correct or not. So plotting the points out is a good way to see whether it's right or not. Okay, please try those. If you have questions, you can raise your hand. In the slide, I skipped some of the methods. If you are interested, you can check the slide. I think they are not very useful. I mean, they are not commonly used. So I skipped some of the functions. But they're in the slides. You can always check them later on. Okay, I hope you are done. Let me think of one exercise for today. So meanwhile, you can continue to practice. Okay, let's go back to the slide. Let me see if I have English. Okay, let me see. Python, NumPy, inverse. Okay, let me try. Let me try a different code, and then I will say. Actually, I don't need to. Just copy here. I want to generate one major. Yeah. Just give me 1 second. Okay. Okay, good. Let's try to do something interesting, okay? I'm going to teach you some math, and then we are going to solve it at the same time. Okay, before I tell you what I'm going to do, I may need to, can I use this part of the board? It's I think I should be able to. Nobody use the back side. I'm going to use it. The board has two sides. Why? How come no one used the second side? It's so new. There's plastic is already still on top. Okay. Okay, maybe I just need a little portion right here. that's enough for me. And since we already learned how to do some linear algebra, let's try to do something fun. Oh, let me see if they. No, it doesn't. Okay. I'm going to solve a problem. Okay. It's a math problem. It's a problem I solve a lot of times in my life. It's an optimization problem, so minimizing a function of f. Okay. So the function is very easy. X1 squared plus 10 x2 squared. So I'm going to tell you, I'm going to do a process that the computer doesn't know the solution is actually 0, 0. The computer doesn't know. When you put a star, that means optimal solution. The best solution that will minimize the function. Computer doesn't know. Yes, optimization. So I'm going to teach you the best solution, the optimal solution that minimizes the solution. Yes. The algorithm is called Newton's method. Okay, and what Newton's method does is like this. The new position equals to any guess minus something called H inverse times something called gradient. Okay? But what is H and gradient? H is going to be partial derivative. It's a 3x3 matrix. So now we know how to define a matrix and we know how to do inverse. We can do this. What is a gradient? Partial derivative. Okay. Let's try it. It will be fun. Yeah, if we can do this, you can guess any point right here and solve for this equation. Newton's method guaranteed to give you 0, 0. Let's try it. So I'm going to put this on the side and I'm going to program this. If you want, you can try it as well, but you don't know how to do derivative yet. So partial derivative. Now, I'm going to use so the partial derivative with respect to the x equals to some delta, and over here f of x plus the delta times the normal basis that I told you earlier minus f of x. Okay, partial derivative, second order. For I not equals to j, you can do this. Oh, I don't have enough space. Okay, how about for I equals to j? So for I equals to j, you can do this. Okay, so what we need to do is to program those. Do we have time? Enough time? If the time is not enough, then maybe we can try this as a homework. Or we can continue next time. So first we need a function, right? So I will need to have a function and function value equals to return the first one square plus the second one squared 10 times, right? Just try it. Y equals to function numpy dot array this. So from here, I wrote a customized function where I have x1 squared plus x2 10 times x2 squared. So this is how I substitute into the function to get the function value, right? If I have an initial get, I have a vector of 1 and 2, I plug in, I end up with something like this. The first one squared plus 10 times the second one squared. So the result is 41. Okay, so try again. Yes, the result is 41. Because 1 squared plus 10 times 2 squared, that's 41. Now I need to have, I need to define something called delta. Let me just say del, or just d for sure. D is a small number, okay? So I need to compute the gradient. So I'm going to say G is my gradient. It's gonna be like an array. And what's inside would be the partial derivative. So for partial derivative, I might just define another function. So do I need a class just like that one? Jason. Okay.
如果这里建一个function，它可以去 call 另外一个 function，还是一定要在同一个 class 吧？哦，好 ，OK， 那可以吗 ？Really？ 要吗
Okay. Let's build a class. Class. So let me call this OPT. Because I need another function which helps me to do approximations. Actually, I think we did this last time, right? So over here, I might need to have a definition of, just like last time, initial and then self. And over here, I'm gonna say self dot d is a small number. Okay, because I'm gonna use this for many times. So define this. We need derivative of x, a self and x. So what we will do is return substituting, so up.func, and when we plug in, we will plug in our x, but this time we will sum a delta. But I need to specify if it's a first one or second one. Okay. So to make our life easier, I can define D as an array, I think. So np dot, so like a delta x and delta y. Np array, and then 0. So dy will be increment in y. Yeah, because here I will only have increment of dx minus the same thing, but no increment. And the whole thing divided by dx, right? This is my first one. So maybe I just call this g. This is my gradient. So I'm going to say g1 equals to this. And g2 equals to this. But here I have increment of y. Okay? So return an array, but this time it's G1 and G2. Return this array. So this is my gradient. Let's try it. So G equals to, now I need to say optimization function. function is fine, but here optimization bracket dot g. Here I'm going to plug in this number. Yay. Okay. G horizontal. My function here. Just double checking. Okay. I need to use debug mode to know what
function 的 x 前面要看一下。
here.
上面
Here?
对
Really? But I'm not using self over here. Do I need to?
Yeah.
Really? Wow. Fine. Like this?
Yeah.
That works?
Yeah.
Seriously? Seriously? No? Function missing one require argument. 13? I need a bracket. No? Oh, I don't reuse it? I also need to do all the brackets everywhere. Really? That works? Still the same. The result is not what I want. Because it should give me either 2 by 1 or 1 by 2 array. That's why I feel it's weird. So I need to maybe pause here. Then x right now is a vector, correct? If I jump in, it comes to here. Okay, define all these. That's fine. Okay, comes to here. X now is yes, this is right. And then I should return a value only. So okay, did this twice. Jump out. G1. How come it has 2 sizes? This is a vector. Function x. This is a number minus another number divided by. Sorry. I divided by a vector. I should divide it by. So let me define another one. Just self.d equals to just a number. Just for the denominator. Just this. Because I use dx and dy just to make my life easy, so that I don't need to make this more complex right here. But I cannot divide it by a vector. That's why. I don't think I need self here. So I'm returning back to my previous one. I don't think I need self for the function. Yep. Because the function doesn't use anything about self. Okay, so I now have the gradient. The gradient is like that. Now I need the Bayesian. H represent Bayesian. So define H self x. Over here I'm going to use something called H11. and then OPT function x plus self.dx, okay, minus 2 times OPT dot function of x plus OPT dot function of x minus this time dot dx. This time too many, divided by self dot d squared. Okay, and similarly your h12 would be the same, but not h12, h22. h22 is the same, but this time you have increment on y. Increment on y. Now h12 is done differently. I have increment of x, and also I need increment on y. Minus the one with increment on x. So I'm just copy this guy. Minus the one with increment of x. Minus the one with increment with y. Plus itself. So no, not here. Okay, it's a long line. With all these, I need to return a Hessian matrix. So return a array of, here the first line will be h11 and h12. Second line will be h12 and h22. That's a Hessian matrix. So let's see if that works. Okay, something is wrong. I'm missing brackets. Oh, I'm missing or too many brackets. Too many here, too many here. Okay, run the code again. Brackets. Too many here. There you go. No? NumPy array. Okay, let me pause right here just to make sure. No? Here, here, here. Pause here. Debug mode. What's the issue? Comma. Forget the comma. Stupid. Okay. Okay. So I should call this H. Hessian is perfect. It's correct. Now the optimal solution, I'm going to call X star equals to the guess. So let me just define my variable. So X guess is an array of points. So I'm going to guess, for example, 5 and 5. But I need this to be a vertical vector. I'm not sure if it's going to operate properly. Anyway, I just plug in here, here, and here. So I'm going to call this f. I have function value, I have gradient, I have Bayesian. So supposedly I need to say x gas minus, I need to do inverse. So numpy linear algebra dot inverse. It's inside a sub method called linear algebra. And I'm going to inverse Bayesian and multiply. Can I just multiply like this? I'm not sure. Can I? Oops. Okay. Just try it. I guess something will be wrong. Okay. Maybe transpose G. No? Let me see what does it look like. Okay, you cannot, do I need to do dot product? Because I'm having matrix multiplying a vector. So it's not the way to do this calculation. Just double checking. Okay. Python. Am I out of time? Matrix multiplication. Okay. Ah, good. So matrix multiply. NumPy matrix multiply. I hope this is it. Yeah, I get it. But before I do that, I'm just curious about this guy. Yes. Okay, let me change my guess. 10, 10. The solution is close to 0, 0, right? Let me change my function. If I have x2 minus 20 over here, change my function. Solution is this is almost like a 0. This is almost like a 20. Okay, let me change my delta here. I can say delta, and here I can just use delta. I reduce delta. Okay, and let me try a different point. For example, here, minus 5. I should get 520. 520. See? So with any guess, for example, any guess, random guess, Newton's method gives me, no? How come? No, that's not right. Why? Why is that? Okay, maybe it doesn't handle negative well. No. Why? Okay. For some reason, if my guess is too large, this is not accurate. Or maybe the error accumulates when this number increases. Yeah, that is possible. It's possible. And I only have, this is a approximation. Newton's method is the gradient is approximation. So if this number is too large, the approximation was not accurate. So it doesn't give me good results. But anyway, let me stick with something small so it looks nice. Okay? So that's it. I did it in time. But I'm not able to show you the whole thing in one. Maybe I turn off this. How do I turn this on? Can I turn off this? Or can I enlarge this? New window. No. Yeah, okay. So it's a practice. So if you cannot get it, and we are a little out of time, and also someone interrupt today's lecture, I'm just want you to use Python to do something meaningful, not just a random exercise showing numbers on the screen and doing nothing fun. I think this is fun. Okay, so the math behind this whole thing is right here. And this is one way to implement what I mentioned right here. I'm going to explain line by line. Now, we need NumPy. So I import NumPy. I need multiple function substitution, so I prepare a class. And I define several functions. Over here, I made good use of the vectors, NumPy arrays. Without NumPy, those math cannot be done so effectively. So over here, I define a bunch of deltas just for me to program this more easily. Delta is just a number. I use self.d. So later on, when I run every code, this self variable can be carried to other functions. So I can use self-d to represent delta. And I have this self.dx. It's a vector, but have increment on x. .dy has increment on y. So later on, when I run the code, when I do this, I need increment on the ith variable. So this is the increment in x or increment in y. So if this is x1, I have increment in x. If this is x2, I have increment in y. Okay? So that's why I have this increment of x, y remains the same. X remains the same, increment in y. Okay? Now my function is defined here. In the below this line, I come to this function, this func, many times. Okay? And over here inside this func, I don't need anything from self. So I don't really use self. I don't really need to. You can, but it doesn't need to go to self. It doesn't need to go to initialization for every time you use func. So you don't need to say self here. But for the gradient, this is my gradient. And this is so-called the Hessian matrix. Let me write down the names. This is called the gradient. And this is called the Hessian matrix. Okay? So I try to compute gradient and Hessian right here. the gradient is going to be partial derivative of the function with respect to x and with respect to y. Over here, I just have increment of x minus the original function divided by d. I have increment of y minus itself divided by d. Then G1 and G2 would be the components inside the gradient matrix, gradient vector. And I return a NumPy array of G1 and G2. That's my gradient. Hessian includes the components of second order derivatives. Over here I have increment of x minus 2 times of the original function plus function value with decrement of x. Here is important. It has to be decrement. Okay? For Hessian matrix, the 2 component, basically right here. It's going to be increment of y, increase the function value, minus 2 times the function value, plus function value with decrement of y, divided by the delta squared. The most complicated part is this one. This is this guy. And this one can be computed by this one. Okay, computed by this. So the math is here, the code is here. You first have both increment in x and y. So if you can define your increments in this way, it's very easy when you use it. You have your original x, increment in x, increment in y, plug in the function. Minus your x with increment of x, plug in the function. Minus the one with increment of y. Plus the function value, original. The whole thing divided by delta squared. So your Hessian matrix looks like this. H11, H12, second line, H12 and H22. H12 is the same as H21. So you only need to compute once. So over here, Newton's method is right here. Your initial gas minus, this is matrix multiply. So what I have here, multiplying what I had on the right hand side. I use what's inside NumPy. There's a linear algebra method, and I can do inverse. INV represent inverse. Because in Newton's method, I need Hessian inverse. Second one, because whenever we define array, they are horizontal arrays. I need it to be vertical, so I transpose the gradient right here. So this inverse Hessian multiplying the vertical gradient, as a result, use your original solution here to minus the multiply, the product. And as a result, it will give you some answer that is very close to the solution. In this case, for this function, the solution should be 5 and 20. Because only if you plug in 5 and 20, you can get 0. Okay? So let's run the code again. See, the solution is very close to 5 and 20, not 0. Yes, 5 and 20. Okay? So go ahead to copy the code if you want. I don't think you have enough time to completely finish this. You can practice at home. I'm not going to check, okay? how do I do that again? New window. Yes. So go ahead and just copy the whole thing and have fun with it. Okay? That's it for today. Any questions? Any Lakers fan here? Go Lakers. Who's a Warriors fan? Shut up. Go Lakers. Okay, yeah. If you if you are done with your practice, you can go. Okay? So there's no homework checking. But if you make it work, just you can just keep practice on your own.
，Amy 要访问
谁是 Amy？
看你会不会靠背啊？我也没办法。